Hello, this is Owen Riley, and I'm welcoming you once again to some Java programming. We're going to look at, inheritance, and this time we're going to talk about inheritance using abstract methods. An abstract method, you might recall from the book, is a method that all it has on it is a declaration, and there's no body, there's no definition to that method. It's just a heading. And we're going to find that an interface, which is what we're going to look at today, an interface is composed strictly of abstract methods. And then those abstract methods have to be realized in any class that uses that sports scoring interface. We're going to see two different versions of our sports scoring interface today. We're going to start with the simplified version. Our sports scoring interface will be used by the football, basketball, and baseball. What we're going to do here is put together scoring rubrics for these various sports that would explain to someone who doesn't know anything about them how the various sports are scored and how you can get points in each game. So that's what the purpose of this system is. And here we see an overview of it. There's our interface, and these are the three classes that we will use to implement that interface. Let's look at the interface now and see what it has in it. Our interface at this point is very simple, and most interfaces are, because all they consist of are method definitions. And you can see I have two method definitions in this public interface sport scoring. One method is called calcPoints, which will be a method that takes no arguments but returns an integer. Another one will be called getScoringRubric, that again will take no arguments, it will return nothing. So whatever it does, it will do its work totally inside that getScoringRubric. Now remember, when someone implements an abstract method that has an abstract class that has an abstract method in it, that class must realize those abstract methods. In other words, we have to give them bodies in any class that uses them. So let's look at our baseball class first. That's our simplest one, and all of our sports classes will be pretty similar. Remember, let's go back and look at our hierarchy one more time. This baseball class is going to come directly off or use that sports interface. So we know that our baseball class must have at least two methods, one called calcPoints and one called getScoringRubric. So here is our baseball method. Notice the way we say this is that we say that the public class baseball implements sports scoring. We've seen that word implements before when we've done some work with action listeners. We would say that we implement action listener. Well, there'll be one instance variable in baseball, and it will be runs, because in baseball we keep track of points via runs. We'll have one constructor right here. It will be public baseball. It will take new runs. It will call it super, which again is sports scoring, and then it will set its instance variable runs to whatever is sent to it. Then here's the concrete methods that bring to life those abstract methods. Here's our getScoringRubric. Notice the heading matches what you saw in the interface. And this simply tells us baseball scores 1 point for each run scored. And it says that a team with so many runs, let me lengthen this out a little bit, has a total of, and then we call this method called calcPoints. Can't quite get that on there. Let me stretch it out. There we go. Excuse me. So we call this method called calcPoints. CalcPoints will come in here and return score calculations. In baseball, there's a simple calculation. For each run scored, you get 1 point, so to speak. And so that's why in baseball, our calcPoints, its implementation of the abstract method has only a single statement in it. It's going to return runs. These were some testing codes. We don't need to worry about that right now. That was just something I did once before. I should have taken that out. There we go. Return runs. Our other part of our system here was our football scoring method. Now our football scoring method, let me bring that back if I can here easily. Whoops, let's see. I hope I can. There it is. Remember, now we've shown you baseball. We're going to show you football and basketball next. Now the trick will be to get my Eclipse to come back, because sometimes when I'm recording these things, they don't want to come back. Ah, beauteous. All right, it's back. All right, so let's look at that football method. Now the football has a lot is a lot more complicated than baseball. So if you don't know anything about football, we're going to teach you right now. If you know everything about football, well, I guess I can't teach anything, but that's okay. So once again, from the programming point of view, we're going to say public class football. Notice the class names are always capitalized. Know your naming rubric. We're going to enforce that more and more now. Public class football implements sport scoring just as before, but there are a couple of ways in football to score. First of all, you can get 1 point for an extra. You can get 1 point for a field goal extra point. You can get 2 points if you run or pass it over for an extra point. A field goal will get you 3 points. A touchdown will get you 6 points, and a safety will get you 2. So we have to translate all that for our user so that they will be able to understand how football is scored. So here's our constructor. We take all this information in. If we're going to give our user an example and then print back the results, we're going to say call our super again, and then we'll set all these instance variables with these. Remember, these are what the users are sending us, or the client is sending us. In this case, that's going to be our driver or our tester program, known as the client. It's the one who uses these classes. Now our get scoring rubric here, it's a lot bigger than baseball's because there's a lot more going on in football to explain. Football scores 1 point for each kicked extra point, 2 points for each other extra point, run or pass. Scores 3 points for each kicked field goal, 6 points for each touchdown, 2 points for each safety. And then, as before, we will print out an example using the printf command. We'll say this example shows a possible score, and then we'll calc points. Now remember, the example is going to be based on what was sent in the constructor, and these instance variables were set to. So in our calc points, this is how we score in football. Extra 1 plus extra 2 times 2. If you want, you could put these in parentheses just so you could be more clearly as what was happening, but they don't have to be. We can say field goal times 3, because if you get, say, 2 field goals, you're going to get 6 points, so it's field goal times 3. Touchdowns times 6. I score 6 touchdowns, I get 36 points. And if I have 12 safeties, that means I got a heck of a defense, then I'm going to score 24 points. So what we'll do is this is where we'll calculate the points just as we saw before. We're going to call this toString here. Whoops, excuse me. To get the scoring rubric, we'll call the toString. Here's our toString. And here's where we calculate the points. So we get to call this get scoring rubric, we show the example, and then we return the number of points. Let's show you basketball, and then we'll run our first example for you. As always, enter this code on your own. You'll find all the code in the folder. You just got to enter it, get it under your fingers. Basketball, there are 3 ways to score in basketball that I'm aware of. Notice once again we implement sport scoring. Basket 1, basket 2, basket 3. So this is how we set up our constructor. Notice that when we inherit from these interfaces, or when we implement these interfaces, the setups are going to be a lot alike, because that's the whole reason for this interface is that the processing, although it won't be exactly the same all the time, it will be general enough that you can fit it into your situation. And so you'd expect to see a lot of similarity. So we'll explain basketball scoring. 1 point for each free throw, 2 points for each standard field goal, and 3 points for each long field goal. They are, I looked it up, they are actually called field goals in basketball. We could call them baskets, but they're really called field goals. Anyhow, that doesn't matter. We'll do the same thing. We'll call our toString to display our example. We'll show a possible score of, and then we'll call our calc points. And once again, if you prefer, I usually don't put these parentheses in, but certainly to make it clear for you, there's nothing wrong with putting them in there. And if you want to do it, if it helps you see the example better, that's great. It does not matter to me. Okay, are you ready to test it? Well, now let's find a tester here. Let's find a tester. I know I have one. Sport scoring tester. Alright, here it is. Here's our sports scoring tester right now. We're going to do a couple of different things with it. Notice what we're going to do is we're going to implement a different sport, Sport 1, Sport 2, and Sport 3. I use the word implement, I do apologize. We're going to instantiate a new object called Sport 1 for baseball, Sport 2 for basketball, and Sport 3 for football. Notice each one gives a different example. We send the different numbers. 5 for baseball, these are the 5 runs, these are the field goals, standard points, 3-point goals. These are the listing of the football scores. In each case, then, we call the Sport 1, Sport 2, and Sport 3. We get that scoring rubric. Let's see if it's going to work. Keep your fingers crossed. I mess around with my code sometime. I never know if it's going to work the first time. Okay, this is looking pretty good. All this output is generated just by that. Baseball scores 1 point for each run scored. A team with 5 runs has a total of 5 points. Notice that each of these will be pretty much the same, although they're sport specific, and that's what makes this so powerful. We know that anybody who interfaces with the sports scoring interface has to follow a certain set of rules, but inside those rules they have a lot of flexibility, and that's certainly shown by this. Basketball shows this example, and football shows this example. Now that's all well and good, but let's assume some morning your boss came to you, as they many times do, and say, we would like to add a new sport. We were going to change, instead of just football, we want to recognize soccer as well. So to do that, we're going to have to look at our structure and restructure this a little bit, because we're going to replace football with football and soccer. But we still want to keep the idea of football in here, so what we're going to do is change our interface, or change our hierarchy so it looks like this. Our sports scoring interface now will be implemented by baseball, basketball, and abstract football. Abstract football then will be implemented by American football and soccer. Remember, they follow the implementation trees just the way our hierarchy, we've been looking at the idea of inheritance and hierarchies. That's anything that a sports scoring interface can do, soccer can do as well. Alright, so that's the structure. So let's see what we're going to have to do to change this a little bit. What we're going to have to do first is build an abstract football class. So an abstract football class will look like this. Now the public abstract class, abstract football, implements sports scoring. Notice it has a single constructor, abstract football, that calls the super. Then it has another method called football message that will say this: system.out.println, there are 2 types of football, soccer and American football. So in other words, when someone now brings this system up, if they say they want to learn about football, well, what they're going to find out is, first of all, there are 2 types of footballs, and then we'll take it from there. Notice that the abstract class, abstract football, does not, although it implements sports scoring, it does not have to realize or make concrete the 2 abstract methods in the sports scoring interface. The reason for that is, since this is abstract, it can't bring anything to life itself. It's going to have these abstract methods, have these things realized in the next method. Does that make sense? I hope it does, because that's kind of a little loophole in there. This is a real method in here that will be printed when this comes up. But this still has not implemented the 2 methods that have to be implemented from the sports scoring. Those will now be implemented in our other methods. We still have our football class, but that's not going to be used anymore. This is going to be kind of obsolete, as we say. It's still going to be there, but we're not going to really interface with it anymore. We're going to replace that with a class called American football, which will look exactly the same as our previous football class, except for one key element. And that key element here is, now we're going to say American football extends abstract football rather than implements abstract football. You can't implement a class that has a real method in it. You can only implement abstract things, and then you bring to life those abstract classes. But we can extend this abstract class, American football, and then in here we bring to life the get scoring rubric and the calc points. Furthermore, then, our soccer class will now do the same. It will extend abstract football. Soccer is kept in goals. We will have our our constructor's a little bit got out of place there. Our constructor will take the number of goals just as we've seen before, and soccer, of course, is easily scored just like baseball is. A team with, this time, goals has a total of 5 goals equals 5 points. So now if we come to our sports scoring tester, we can do this. Let me change my comments so we'll activate another part of my tester. This is the only code I haven't given you. If you want to run this, you'll have to take screenshots of this driver. Oops, I didn't want to do that. Oh, I wanted to do this. Dang. There we go. And now we're going to activate this part of the code. Notice what we're doing here is we are saying sports scoring. Whoops, we didn't want to do that one. I wanted to go straight to this next one. What we're going to activate here is the example with abstract football, and we're going to demonstrate two things. Now notice when we did this before, we called each sport and then called its get scoring rubric. Sport 1, get scoring rubric. Sport 1 was a baseball. Sport 2 was a basketball. Sport 3 was our good old football. But now we're going to do this a little bit differently. Instead, and again, this shows you how polymorphism, that fact that you can program in general and then get more specific as you go, it adds power to what you do. Because now we can, we can create an array of the sports scoring class. Now remember, that's our abstract class. We're creating an array of a sports scoring class. And that's okay to do that of these abstract classes, because then what that allows us to do is create an array of that, and each one of these, and since a new baseball is a sports scoring, and American football does inherit from sports scoring, and basketball does inherit from sports scoring, as does soccer, as we saw in our, let me bring our diagram back up here again real quick. Notice how they all inherit from sports scoring. Baseball, basketball, soccer, American football. So since they are all of this type, they are all of this type. So since they're all of that type, we can store them all in an array of that type, have our constructor set up like this, and then we can easily iterate through them using, in this case, a standard for loop. But hint, it would be real good to put this in an enhanced for loop when you have these nice types that you can use. Alright? If there are any questions, please post them in the discussion board. And that kind of will end this discussion of interfaces, which are consisting of only, an interface only consists of abstract methods. Interfaces can be implemented, as we saw in our soccer method, for instance. Soccer classics, that extended abstract football. How about a baseball? The sport's going to be implemented in baseball. If we look at another abstract method, abstract football, we can abstract football can also implement sports scoring, and then what inherits from that now can also implement, whoops, American football, I didn't want that. American football now can also extend abstract football. Okay, that's all for today. Have a good rest of the week. We'll see you next time. This is Owen Riley saying goodbye and good programming.